In some of my upcoming video projects I needed to use a curve tracer. If you're not familiar with curve tracers, I'll go over what they are, what they do and how they work in some future videos. And I was intending to use the curve tracer that I already had, which was a Tektronix 370. Unfortunately, it's so big and heavy that it's almost impossible to make videos that are easy for you to see what's going on. It basically takes up the entire bench, and by the time you've got the project on there as well, it's almost impossible to get everything in shot at the same time. So I've made another acquisition from eBay, and that's this. This is a Tektronix 577. Again, it's a curve tracer. It's a much simpler machine, and although this is still quite a big machine, it's only 1/3 of the size and weight of the 370, so it's much easier to get on the bench. Now, as I say, I got this off eBay. I've got no idea what the state of it is internally. The seller did say that it powers up, but that could mean anything. But as ever, sold as seen, it may work, it may not. Did come with some very nice accessories. These are quite hard to get hold of if they don't come with the machine, and there's quite a nice little selection of them that will make this machine far more useful. And as I say, I'll go over what it's for if you're not familiar with these machines in a later video. In this video, just have a quick look at it. I've just unboxed this, so we'll be looking at this together. I haven't opened it yet. I haven't done anything other than take it out of the box. It was very well boxed, so the damage that's on here wasn't done during transit. This was already damaged before it was shipped. The seller did point out this damage before I bought this, so it was very well boxed. He made a very good job. He put wood on both sides, double boxed it. Can't complain about that at all. And it turned up, it seems, in exactly the same state that he sold it in, so that's quite nice. You're never quite sure what's going to come out of the box when you buy something off eBay. So there are a few damaged knobs on here. If you do have any old Tektronix knobs that you want to sell, then please contact me. I need some of the kind of medium-sized tabbed. Ideally, I'd like to replace this knob, it is damaged. Another one down at the bottom, that's the round version of this, and then some of the smaller ones. So if you've got any old Tektronix knobs lying around, then please let me know. So on first inspection, needs a good clean. It's very dirty, and this is loose, but I think it's just popped out. This can be put back in. So if I just take the two screws out, this is a photographic mount. So these were quite popular sort of years ago when you wanted to take an image of what was on the screen, and you could clip a camera mount onto these, which is why they've got slots at the top and the bottom. And you could take it off completely to put a complete separate mount on here. But it's popped out of one side, but it doesn't look broken. I think it's just a case of taking the screws out, popping it back in, and seeing if it's going to fit in there okay. I don't think the case is distorted, it just looks like it's popped out, possibly chipping, but it doesn't look damaged. The main thing is whether or not the tube has survived, because obviously that would be probably end the project if the tube's not working. It's got the shield as well, so all quite nice. You do kind of need this because it operates a switch to apply power to the device you're testing. Corner capable tester, it will go from 0 to 1600 volts and 0 to 10 amps, not both at the same time. The current is progressively limited as the voltage increases. I think it's something like 40 milliamps at 1600 volts and 10 amps at 6.5 volts or something like that. Again, the switch is damaged down here, but the first thing I need to do is to open it up, have a look inside. Looking at the mains power cord, it has got a US power cord on here, so I'm assuming this is set to 120 volts. So we'll spin it around, have a look inside, and change the jumper settings. It's quite easy to change the voltage settings on these machines, but it will also give us a chance to have a look inside and see what the general condition of the unit is. So I'll get it spun round and we can take the back cover off. Okay, so looking at the back, unfortunately it has received a bit of a whack during shipping. There's looks like it's fairly fresh, so it has been pushed in. These are heavy machines, so it's probably fairly inevitable this will happen unless there is some very specific packaging, but you can only go so far when you're shipping these unless you're a professional shipping company. So the first thing I'm going to do is take this cover off and make sure that the tube base isn't smashed, because as I said, if the tube's damaged then there's no point in looking at the rest of the machine because the chances of finding a replacement tube are pretty much zero. So we'll take this off first, have a look, and hopefully it is just the outer cover that's damaged and I will be able to straighten that out. Okay, so yes, fortunately the tube itself looks fine. Just looks to be a long way forward, but it's not broken and I can't see any signs of any damage or any contact marks on the inside, so that looks quite good. I can straighten this out and repaint it, so that's not a big issue. So the next thing I want to do is get the rear cover off so we can set the voltage correctly. It does actually say on here that note's currently set to 120 volts, whether that's a recent sticker or just been on there for years and no one's ever bothered to take it off, I don't know, but we better check before we try applying power. So we'll take the screws out. There should just be a couple of jumpers in here that you swap over depending on the general range, and then you select a position based on the exact voltage you want to set it to. Okay, so these are the jumpers in question. This end slot is just a parking space for the jumper, and you use the red jumper. You can kind of see what's going on here. You've got a pair of jumpers or pair of jumper wires on this connector and a single one on here. So the way this works is you use the red connector for the sort of 200 240 volt range, and then the brown connector for the 120 range. And so this just comes off here. Then you have three positions. You've got a high, a medium and a low, and that will give you a range something like 220 230 240 volts, or 110 120 130 volts. So we want the high range, so we want to put the red jumper on high. We can then put this onto the parked position. It doesn't actually do anything, it just stops you losing it. And in theory this should now be in the 240 volt range as far as the transformer is concerned. What I'm going to do is just double check this. As with all old machines, I do like to check that what I'm doing makes some sense and do a kind of sanity check. So I'm just going to get the test meter. Okay, and we'll grab the mains lead. I'm just going to connect the test meter. It's in ohms range. I'm just going to connect it across the mains lead, and because this is a linear transformer power supply, we should see about twice the resistance in the 240 volt range than we do in the 120 volt range. If it works out the other way around, then we've got these reversed. So I'll just pop this back off. I'll put the 120 volt jumper back on, and we should see about half the resistance we were just seeing. So it was about 7-8 ohms, and we're now seeing 2.4. So that sounds about right. I can put them back. Again, it should return to about twice that resistance. It won't be quite, it'll be actually more than twice because the high voltage windings are thinner, so it will be slightly higher resistance, but we can see that it is going the right way. So we've got this in the right position. 2.81, if I move it into the lower, or I'll put it in the middle slot, we can see it's gone down, and it should go down further again in that position, which is the low voltage in the high range. So that would be the 220 volt. So I put it back in 240. I've got fairly high mains voltage here. Put it back in that position. Now I can already see I shouldn't really turn this on. I've got a tantalum cap here that has spilled its contents. It should be yellow. It's almost black, and I can see the insides coming out. Should be the same as this one, and that will need changing before I put any power onto this. The fuses look intact. We'll just check those. So that one's fine. That one's fine as well. Okay, so what I'll do now off camera is replace this tantalum capacitor. I'll check the other larger caps to make sure they're fine, and then we can try and power it up. Normally I wouldn't power something up without going through it first, but just to make the video a bit more interesting and so it doesn't take too long to hopefully see something, I will power this up, and then if anything does happen we'll carry out the necessary repairs. Okay, for the initial testing I've just removed the capacitor. Because of where it is, the circuit will work without this fitted, so if everything's fine I'll put in a replacement, but for now I'll just get it out of the way. I've got the infrared camera on standby, and what we'll do now is power this up. I've got it attached to the bench variac, but we'll just go for broke. I'm going straight up to 220 volts. I've got the multimeter common connected to chassis ground, and there are some test points along the back of the board here, so there are 4 supplies that we need to check. It's a linear supply, and it's basically winding from the transformer, goes through the rectifier, smoothing capacitor, and then onto a regulator, and there's a regulator for each of the rails. So I'll power this up, and I have got safety glasses on just in case any of these capacitors decide that they want to make a break for freedom, and we'll test the rail voltages and see what's happening. Okay, so nothing spectacular so far. It's drawing 250 milliamps from the main supply. We'll check the various rails. This should be plus 30 volts. Close enough. This one is minus 30. Again, close enough. And this one is 200 volts. Again, close enough. Minus 12. Again, minus 2, so that does not look right. And plus 12. Is fine. So the only one we have an issue with is the minus 12. So if we look at the incoming voltage, that does not look right. Okay, so obviously something is amiss with this minus 12 volt rail. Still sitting at minus 2.2. But looking at the schematic, it's just, as I say, a winding from the transformer, goes through a bridge rectifier, and then onto a smoothing cap. So chances are the smoothing cap is shorted, so I'll turn the power off. I'll look at the schematic, see which particular cap this is, and we'll just have a quick look through the infrared camera and see if we can see anything that's possibly getting hot. And indeed one of the bridge rectifiers is heating up quite quickly. I'm just going to move the camera so that you can see the image on the infrared camera. Okay, so the bridge rectifier is the one at the end. Don't know how well you can see, but there's a row of 4 bridge rectifiers down there. And if I look at the row through the thermal camera, you can see that they're all fairly cool, apart from the one at the end. So I'm just going to check on the schematic and see if that is the one for the minus 12 volt rail, and we'll go from there. Okay, so I've checked, and that rectifier is indeed the rectifier for the minus 12 volt rail. That's the one that's getting hot, and The smoothing capacitors are this one and this small red one. Now this little red one appears to have been changed at some point, so it looks like someone may have already been chasing this. So we'll measure across that and we're getting 19 volts, which is correct. If we measure that relative to ground, that is correct. So we are getting the right voltage going into the regulator. So we either have a problem with the regulator or the problem is downstream, and possibly there's something else in the machine that is dragging that voltage down. So what I'm going to do is disconnect the connections that go to the rest of the machine and see if that minus 12 volt rail recovers, and if it does, we can be fairly confident that the fault lies somewhere else in the machine. But at least it will eliminate the power supply. Otherwise we can look in more detail at the supply itself. Okay, so I tried unplugging the connectors that go to the rest of the machine and it made no difference. I was still getting about the same voltage on the minus 12 volt rail. I've checked the capacitors. I don't think it's that, because we're getting 19 volts going to the regulator, but there is a what appears to be a short or partial short across the minus 12 volt rail. There is a protection diode that goes from that rail to ground to prevent the voltage going in reverse if when you power the machine off. I tested that, that's fine. So the only thing left really is the regulator. So what I've done is I've lifted the center pin of the regulator. Now it's actually the ground pin. This is actually a positive regulator, but it's being used in a manner that allows it to create a minus 12 volt regulated rail, and it means that the what would normally be the ground pin is being used as the output. So what I did is I've just lifted, you probably can't see, I've lifted the center pin of the regulator, and what I'll do now is measure the voltage coming out of that relative to ground, and it should be minus 12 volts. So we'll power up the machine and we'll test the voltage coming out of the regulator. And as you can see, we're not getting anything at all. So we'll switch to ohms. I've turned the machine off and we'll measure across the pins on this regulator. So this is the output to the ground pin, what would normally be a ground pin, and as we can see there is in fact a short on this regulator. So it looks like it's the actual regulator itself. So I'll get this popped out, I'll put in a new regulator and see if that restores the minus 12 volt rail. Okay, so I've got a replacement regulator temporarily tacked in. Someone's definitely been here before. The insulation bush has been pretty much destroyed, and the screw that was holding it in place just seems to have been put through and hammered over, so I'm not quite sure what was going on there. But I've got a new regulator in, we'll power it up and see if we've got the minus 12 volt rail back. So we'll go from ground to the minus 12 volt test point, and we do now have the minus 12 volt rail back. I'll make sure that we still have the other rails. So plus 12, 200, minus 30, and finally plus 30. So they're all looking fine. I won't leave it on too long because obviously this regulator is not heat sinked at the moment. So I'll get this tidied up, I'll dig out or make up a new insulator for it, replace the screw and replace the capacitor, and then we'll get it powered up and see if anything appears on the screen. Okay, so the original insulation bush is completely destroyed on this, so obviously I can't use that. I couldn't find one this size, it's a bit of an unusual size, so I've made one up on the lathe. So this is just like a top hat with a recess, and then the screw fits into the back. This is on the outside, and the idea of course is that the screw is recessed and doesn't stick out too far on the back of the machine. So this then goes through the rear panel, the new regulator sits on the front, and we should be able to get it all bolted in place, reconnected, and so we can then see if it still works. So I'll get that done, and then I'll get back on camera, and we'll do a final test on the supplies and power the machine back up. Okay, so I've got the new regulator in place. We'll power it up again and see if all the voltages now check out. So power is on, measuring from ground as usual, and the first one should be plus 30, which it is, then minus 30, plus 200, and now minus 12, which is now fine, and finally plus 12, which again is fine. So all the voltages are looking fine. Power the machine back off. I also put a top hat on the inside end of the bolt, so as well as being insulated on the outside, it's insulated on the inside, because I didn't want to have minus 12 volts on the head of the screw. So even though it's recessed, it still would have had minus 12 volts, and there's a very possibility it could have shorted to something. So I wanted to avoid that. Give the board a quick clean. I'll get this bolted back in place. I'll remove the set to 120 volt sticker, because obviously now it's set to 240 volts, and then I'll spin the machine round. We'll try powering it up and see if we can get anything on the screen. Okay, so looking at the front, I did incidentally replace the capacitor that I'd removed, and the power supply seems to be fully functional now. So what we'll do is first power up and see if anything appears on the screen. So obviously we have some power somewhere, and the power light is on. You do of course need to be careful with machines like this, because they can put out well over 1000 volts on the test fixtures, and we are getting a dot on the screen. Of course there's no component in here, so we won't get any active profile showing, but we should be able to get it to scan in a straight line, simply because there will be effectively an open circuit component in there. So if we turn this down, we're currently on 100 volts per division, so we'll turn this down, and we are now getting some deflection. Bring it down into a sensible position. Okay, and this should now allow us to alter the voltage sweep that's been applied to the fixture, which it is doing. So far it looks like we should be getting some activity at least in here. I don't know if it's going to be stepping, I don't know if the rest of the circuits work. I have refitted this cover, by the way, given it a clean, and cleaned the entire front panel, removed all the scuffs. There was some fairly bad scuffing around here. So it's starting to look quite good, but I need to now replace the switch that's broken on the front, and start trying to find some replacement knobs. What I'll do in the next video in this series is we'll test a few components, see if we can get a sensible plot on the screen, and we'll be looking of course for curves for various semiconductors, and we'll see if the machine works, and deal with any faults that we find. As I said, if you do have any knobs that you think may fit this, then please let me know. I need the large voltage control knob, I need the collector voltage knob, which is similar to this knob here, just a plain one, and then I need a small knob and the larger version of this as well, and one of these dual knobs. This is the one with the outer pull setting on it. So if you've got any of these knocking about and you want to sell them, then please let me know, and as I said, in the next video we'll get around to trying to see if this works.